Hello and welcome. In this video, we are going to learn about how we can solve the particular integral of type 1 where the f of a is equal to 0. Okay, let's get into the problem now. So in this, we are going to solve the particular integral. We are going to find out basically the particular integral of the given equation d square y by dx square plus 7 times dy by dx plus 6y is equal to e raised to the power negative x. Well, you see that the independent variable here is x. How do we find out that? Okay, you see the indicator that on the right hand side of the equation, the non-homogeneous part is completely made up of x. And the denominators are x's again. So the independent variable is x and the dependent variable is y, my friends. Now we write down the symbolic form of the given equation, right? So d square y by dx squared is the second order derivative term and dy by dx is the first order derivative term. So we will, reduce these terms into the operator format. So we'll use the capital D operator, which is the differential operator with respect to x. So the symbolic form becomes d square y plus 7 multiplied by dy plus 6y is equal to e raised to the power negative x, right? So capital D square y is basically the second order derivative of y with respect to x. So that's the operator algebra that we're using. So again, using the closure property of operators, we can take out the y outside and we can write d square plus 7d plus 6 of y as equal to e raised to the power negative x. And so the next step would be to find out fd, r, and a, right? So fd is d square plus 7d plus 6, and then the r is the right hand side, which is e raised to the power negative x, and as the coefficient of x in e raised to the power negative x is minus 1, so a is going to be equal to negative 1. Well, hence the particular integral is going to be e raised to the power x divided by f of d, right? So that is e raised to minus x divided by d square plus 7d plus 6. Now we shall find out what is f of a. Now since a is equal to negative 1, f of a is equal to f of negative 1. And then we'll, in order to find out this particular number, we substitute d as equal to negative 1. So in the expression of ft. So what we get is negative 1 whole square plus 7d plus 1. So there is negative 1 whole square plus 7 multiplied by negative 1 plus 6 is equal to 0. That gives us, oh, wow, it's 0, right? It's a problem. What do we do next? So if our fa is equal to 0, we find out f dash a. Now, the method to find out f dash a is as follows. First, we find out what is f dash d. So here we'll take d as the independent variable and we will find out the differentiation of fd. Recall that fd is d squared plus 7d plus 6, right? So d by dd of d squared plus 7d plus 6 will be 2d plus 7, right? So d square is going to become 2d and 7d is going to be 7 and 6 is going to be 0. It is going to just vanish. So again, we'll find out f dash of a. So f dash of a is equal to f dash of negative 1 because a is equal to negative 1. And then we'll substitute negative 1 in place of d in 2d plus 7, and that would give us 2 multiplied by negative 1 plus 7, which is equal to 5. And this is not equal to 0. Hooray! And that gives us the particular integral to be equal to x multiplied by e to the power negative x divided by f dash of a. Now we substitute the value of f dash a because f dash a is not equal to 0. We have seen that in the previous, just in the previous line. And that gives us x multiplied by e to the power negative x divided by 5. And that, my friends, is the particular integral in this type. Thank you for watching.